The human body is amazing in what we can train it to do, but none of these incredible feats would be possible without our bones and skeletal muscles. So how do muscles and bones work to allow us to move in so many ways? And what makes a muscle contract? You'll find the answers to these and other questions as we explore the skeletal and muscular systems. Not all organisms have skeletons. Single-celled organisms, like the amoeba and paramecium, have no need of a skeleton. But as organisms become more complex and increase in size, they develop the need for a support structure of some kind.
As an organism gets bigger, unless it's suspended in water, it needs to have some sort of a rigid framework. And that allows it then to move that rigid framework to produce movement for the organism and to allow the organism to be organized so that soft tissues can be supported by something more rigid.
Insects and crustaceans have an exoskeleton, a tough, rigid protective layer on the outside of their bodies that provides strength and allows for a degree of movement. Large, complex organisms, like human beings, have endoskeletons, skeletons on the inside of their bodies. Although the tough outer armor of an exoskeleton is missing, our endoskeleton still provides protection to our vital organs and systems. The skull completely encases the soft tissue of our brain. The sternum and the rib cage protect the heart and lungs from damage from the outside environment. And the bones of the pelvis cradle our internal organs. In addition to its protective function, the skeleton also provides a strong supportive framework to which all of the body's tissues are attached. A third function of the bones is movement. Our skeleton also plays a role in vital body functions, such as chewing our food to aid digestion and creating blood cells in the bone marrow. Bones are also reservoirs for essential minerals, such as calcium and phosphate. One final function of our bones, one you probably haven't thought of, is communication. Tiny bones in the middle ear transmit vibrations from the tympanic membrane to the inner ear, where the auditory nerve is stimulated, allowing us to hear. And a special cartilage forms the larynx that allows us to create vibrations that become speech. Along with the bones are the skeletal muscles that provide us with support and allow us to move. These muscles are called voluntary because their movement is under our conscious control. Involuntary muscles control vital body functions without our conscious direction, such as the beating of the heart, breathing, or the digestion of food. Muscles also play a role in balance and stabilization of the body. Finally, our muscles generate heat. If the body's core temperature drops below a normal 98.6 degrees Fahrenheit, skeletal muscles undergo uncontrolled spasms or shivers to restore the body's temperature. The human body consists of 206 bones, which scientists classify into 4 groups: long bones like those found in the arms and legs, short bones found in the wrists and ankles, flat bones such as the scapula and the sternum, and irregular bones such as the vertebrae and hip bones that don't fit neatly into the other 3 categories. The skeleton itself is further divided into the 2 categories of axial and appendicular for ease of study and reference. The skull is the part of the axial skeleton that encases the brain and provides support for the teeth. 2 orbits on the front house the eyes. Below are the nasal bones and nasal cavity. Small air-filled pockets on either side of the nasal cavity hold the sinuses that connect with the respiratory system. The maxilla anchors the upper row of teeth. The jawbone or mandible holds the bottom row of teeth. Attachment points on each side are rounded and connected in such a way that allows the jaw a wide range of motion. It is this mobility that makes it possible for us to chew our food and talk, but preferably not at the same time. The cranial vault is made up of plate-like bones that meet at lines called sutures. The cranial vault, together with the cranial base, provides a secure cavity for the brain. An opening at the base of the skull serves as a point of entry for the spinal cord. The vertebral column surrounds and protects the spinal cord. When we are born, it consists of 33 separate bones or vertebrae, but as we age, some of these vertebrae fuse together. The 4 at the bottom form the coccyx or tailbone. Just above the coccyx are another 5 fused vertebrae that form the sacrum, the point of attachment for the hips. Above the sacrum are the unfused vertebrae. The top 7 cervical vertebrae are the smallest, lightest, and weakest vertebrae. Next are the 12 thoracic vertebrae. In the back, the thoracic vertebrae form the attachment points for the ribs. The 5 lumbar vertebrae increase in size as you move downward. The third component of the axial skeleton is the bony thorax or rib cage, which consists of the sternum or breastbone, the ribs, and the 12 thoracic vertebrae mentioned before. The first 7 ribs on each side are called the true ribs because they connect directly to the sternum through short pieces of cartilage called costal cartilage. The next 3 are called the false ribs because each is connected to the cartilage of the rib above it rather than directly to the sternum. The remaining 2 floating ribs don't connect to the sternum at all. The appendicular skeleton consists of the appendages, or additional parts that are attached to the axial skeleton. The arms and hands are connected through a series of bones called the pectoral girdle.
One of the most interesting things about the pectoral girdle is that all of the bones join together with very loosely fitting joints. This gives our arms and shoulders a very wide range of motion, much more than we find in the lower limbs.
The pectoral girdle consists primarily of the clavicle or collarbone that is attached to the sternum on one end and the scapula or shoulder blade on the other end. The upper arm, also called the brachium, consists of a single long bone called the humerus. The forearm or antebrachium consists of the radius and the ulna. The ulna is slightly larger than the radius. The carpus or wrist consists of 8 small carpal bones that fit together almost like a jigsaw puzzle. The hand itself consists of 19 bones. The 5 bones of the palm are called metacarpals. If you make a fist, the knuckles are the ends of your metacarpal bones. The 14 remaining bones of the thumb and fingers are called the phalanges. The lower appendicular skeleton is attached to the axial skeleton by the pelvic girdle. The pelvic girdle consists of the ilium, the ischium, the pubis, and the coccyx and sacrum. A ball and socket joint joins the femur to the pelvic girdle. The femur is the longest bone in the body. The other end of the femur joins the tibia, the larger and stronger of the 2 lower leg bones. The other leg bone is the fibula, which is situated parallel to the tibia. The patella, or kneecap, strengthens and protects the knee joint. The distal or far end of the tibia and fibula are connected to the tarsal bones of the ankle. The bones of the soles of the feet are called the metatarsals. And like the hands, there are 14 bones in the toes called phalanges. The bones of the feet are positioned to form arches on the soles of the feet. Flat feet or fallen arches are the result of ligaments that hold the arches in place becoming stretched out. This often makes walking and standing difficult and uncomfortable. The bones of the skeletal system come together or articulate at joints. Joints are classified into 4 major categories: fibrous, cartilaginous, bony, and synovial. In fibrous joints, such as the sutures of the skull, collagen fibers extend from one bone and integrate into another, binding adjacent bones together and keeping them from moving. Cartilaginous joints join 2 bones together with cartilage, such as the joining of the ribs to the sternum. Bony joints, such as those found in the sacrum and coccyx, occur during the normal aging process, when 2 bones that were previously separate fuse together. In synovial joints, such as the knee, a special fibrous joint capsule provides a sac-like pad surrounding the joint that is filled with fluid. Synovial fluid constantly bathes the joint. reducing friction as the two bones move. Synovial joints can be classified by their structure. Pivot joints and ball and socket joints allow for movement in many directions. Hinge joints and gliding joints allow bones to move in only one direction. Saddle joints and condyloid joints, such as those joining the thumbs to the metacarpals, allow bones to move in two directions. As strong and functional as the skeleton is, it wouldn't do any of us much good without muscles to move it. Muscles come in a variety of shapes and perform a multitude of functions.
There are muscles with very broad origins and tight insertions. There are long and thin muscles. There are short and fat muscles. All of these different